To the Unit 6 review solutions, make sure that you study well for the first part of the final on Friday. You will definitely want to spend some time reviewing Unit 6, but it could include information or skills from other units, so don't leave those out in the cold. Take a look at Unit 5 and make sure you remember some of those aspects as well. Okay, so radian measure. Remember we started by talking about how radian sounds very much like the word radius, and in fact measures the number of radius lengths in the arc that closes an angle. So when you see the word subtends here, what we're thinking about is if we have some angle, so our initial ray is the positive x-axis, and then we rotate some degree or radian measure, and then that's where the angle stops. And so the arc that has been created around the unit circle, that we had to travel around the unit circle, is the radian measure. And the reason that it's just the length of the arc is because if you think about the number of radius lengths that are in this arc, what you're doing is you're dividing up your arc length by the radius. But since the radius is 1, you'd be dividing something by 1 and just be getting that something. So the angle measure in radians is simply the arc length of that angle around the unit circle. Cosine, sine, and tangent. The sine of an angle x, so say this were my angle x here. I rotate that many radians. The sine of that angle is the y-coordinate at the point where the terminal side, where my angle stops, intersects the unit circle. Cosine is the x-coordinate. And then tangent is the ratio between sine and cosine. In other words, sine being the y-coordinate and cosine being the x-coordinate, we can think of tangent as being the rise, so the y-coordinate, over the run, or the x-coordinate, and therefore is the slope of the terminal side of the angle. All right, so finding the sine, cosine, and tangent, of course, is made much, much easier using our unit circle and thinking about the rotation around in terms of radians. When we're making sense of tangent, what we're looking at is, does the terminal side seem to have that slope? In other words, if I'm in this quadrant here, I'm noticing that all of these terminal sides have a positive slope. So if I were looking for the tangent of pi over 4, I should be expecting a positive number. Similarly, in the second quadrant, all of these lines have a negative slope, and so I should be expecting a negative number. 16 pi over 3, if I rotate around the circle one time and go 2 pi radians, how many pi over 3s is that? Well, that's 6 pi over 3s. Around the circle again would be another 6 pi over 3s, or 12 pi over 3. And so if this is 12 pi over 3, having gone around twice, then this will be 13 pi over 3, 14 pi over 3, 15 pi over 3, and 16 pi over 3. And so that is where the angle 16 pi over 3 is after going around the circle twice. Negative 5 pi over 4, there's a couple ways to think about this. The first is that I'm rotating clockwise, and then 5 pi over 4 radians, how far is that? Let's look at that arc length by looking at positive 5 pi over 4. So that would be an arc length of halfway plus another pi over 4. But I'm rotating clockwise, so I'll rotate clockwise halfway plus another pi over 4. And so this is where negative 5 pi over 4 is. Another way of doing that is simply rotating positive 5 pi over 4 and then reflecting over the x-axis. And that's where negative 5 pi over 4 is. So we can see that tangent should be negative. Finally, for pi over 2, the tangent is the slope of this line, and so does the rise over the run. In other words, it is 1 divided by 0, which is, of course, undefined. It is impossible for you to tell me the slope of this line because there is no x direction component, and so you can't tell me how much it's rising every 1 unit that it runs. All right, so now looking at the amplitude, period, midline, and phase shift, these should be pretty straightforward. If there are any questions, you should probably refer back to your notes. The one thing that is probably worth talking about is Of course, your midline is a line. It's not 1. It's the line y equals 1. Your period is pretty straightforward, right? We're looking at whether we're speeding up or slowing down the number of, or how long it takes to go around our circle. And so that can be defined as 2 pi over the b parameter. If you need to, of course, go back and review that, I do a little example of trying to make sense of the period. And then the phase shift depends on our h parameter, and of course a positive h parameter will shift my function or translate it to the right, and so I have pi over 2 units to the right, and for function b I have 2 units to the right. It would be very helpful to practice graphing these, so as a little more practice you can try graphing these. One note there is that for function a, it's best to graph it with a graph where you're counting by pi over 2 each tick mark. But for function b, it'd be actually more helpful to graph it just counting by 1 every tick mark. And you'll see what I mean when you do that. All right, so graphing functions, remember we want to take advantage of the information that the parameters give us. You can make a t-chart, obviously, and just plug in, different values of x and evaluate your function, but that will take you longer on average. So we want to be as efficient as possible, and so to do this, we want to take note of the key things that we can pick up. So going back and reviewing this section would definitely be helpful if you haven't already. So first thing that I pick up on is that the max of this function is going to be 2, the minimum is going to be -2, my midline is 0, and my amplitude is 2. That's y. And so then I am going to try and plot an initial point, and the point that I'm going to plot is the point that is kind of native to cosine, if that makes sense. So what I mean by that is a cosine function without a phase shift will have a y-intercept at its maximum value. However, this is not a cosine function without a phase shift. It's a cosine function with a phase shift pi over 4 units to the right. And it's being multiplied by a negative. So what was a maximum is now going to be reflected over the midline, is now going to be a minimum. And so the y-intercept of a negative cosine function without a phase shift would be the minimum, and this one is phase shifted to the right pi over 4 units. So there would be a y-intercept here, but it has a phase shift, so it has been translated to the right pi over 4 units, and this will be an initial point that I can plot. Taking advantage of this now, I notice that this is a minimum, so I can plot another minimum by moving 1 period to the right or left. So I'm going to move pi units to the right. If this is pi over 4, I want to travel to 1 pi and a fourth over here. If you're curious about how I got there, I notice that this is pi over 4, so I can simply do the calculation. Pi over 4 plus pi, and when I get a common denominator, I'll get 5 pi over 4, and if you look on your unit circle, you'll notice that this is halfway between pi and 3 pi over 2, or another pi units to the right. And halfway in between my minimums, there must be a maximum. Maximum value is at 2, so there's a maximum there. Halfway between max and a min, it will intersect the midline at y equals 0. And from there, I can complete this by finding another maximum, a couple minimums, so on and so forth. And there it is, minus a couple of my really great drawing skills. All right, now let's take a look at the next function. All right, so for the red function, picking up that the midline is the line y equals -2, and you could even sketch a little dotted line across y equals -2 to help you remember that. And then from the amplitude of 3, we can see that the maximum is going to be 3 above -2, which would be +1, and the minimum will be 3 below, which will be -5. There is no phase shift, so a sine function without a phase shift will have a y-intercept at the midline. And so my y-intercept will be at the midline of y equals -2. And that's the first point that I can plot. Now, the next step for us is, we need to find a maximum or a minimum. That would be very helpful because then we could use the period of 4 pi to find other maximums and minimums. So what we need to do is decide when will we have a maximum? And we'll have a maximum for sine, since there's no negative, it's positive sine, will be at its maximum value of 1 when the argument is pi over 2. So what we need is we need 1/2 x to be equal to pi over 2. We need to figure out what that x value needs to be. And so you can multiply by 2 on both sides, and you'll find that that means that your x value you need is pi. And so you know that when you plug in an x value of pi, you're going to get a maximum value, which will be 3 plus -2, in other words, positive 1. So when you plug in pi, you'll have positive 1 here. Okay. And now you can look to complete your function using your period. Notice here that 4 pi extends beyond our graph, so we can do our best here. 1 pi, 2 pi, 3 pi, and then this looks to be 4 pi right about there. And that's where we'll have a maximum. And then halfway in between we'll have a minimum. Well, halfway would be a 2 pi distance. So we have 1 pi, 2 pi, so that means a minimum is going to happen down here. And at this point you can sketch your graph. I do want to show you a couple of other interesting points. One is that if you know this midline point, and you know that it will take pi units to get to your maximum point, well, then you know that you're going to get to back to your midline another pi units after that, or down here. And then you're moving the other way, you know that it'll take pi units to get to your minimum point. So pi units to the left, you get to a minimum. And then another pi units to the left will be at the midline again. And so we can finish sketching our graph. Right, so building a function, we know that we need to figure out the parameters and whether we want to use a sine or a cosine function. So first we'll start with the easy stuff, finding the maximum and minimum values, using that to find a midline. So maximum of 1, minimum of -3, it gives us a midline of y equals -1. So of course in our function we now know the k parameter will be -1, and we know that our amplitude is 2, so we know that our a value is going to be 2, and we might want to make it negative, but probably not, so our a value will probably be 2. Next, we want to figure out what the period is to help us understand what we should use as a b parameter. And so the period, the distance between consecutive maximums or minimums, is a distance of pi units. So the period is pi, but remember, b is not the period, right? The period is computed by taking 2 pi and dividing by b. So to solve for b, we need to understand what would we need to divide 2 pi by to get pi. And you could solve for this by multiplying by b on both sides and then dividing by pi. But you should also just notice that it's pretty obvious that b must be 2, because 2 over 2 would be 1. And so the b parameter will be 2. Now, the next thing to decide is whether or not it's easiest to use a sine or a cosine function. And remember, the way that we think about this is by looking at the phase shift and thinking about how sine or cosine usually works if there's no phase shift. So if there's no phase shift, a sine function will have a y-intercept at the midline and then increase. Well, let's see if that works. Our midline is y equals 1. The y-intercept is at y equals 1, and then that is increasing. So this would work for a sine function with no phase shift. And so this allows us to write our first function, y equals 2 sine, the b value is 2 x, there's no phase shift, minus 1. Now, if you haven't already, try writing a cosine function, and I will take us through the 2 different ways that we can do that. So the first way is just to go back through, and when we're deciding, between sine and cosine, we're going to say to ourselves, okay, what would have to be the case for it to be a cosine function? And so we know that a cosine function with no phase shift will have a y-intercept at the maximum. But this graph here, the maximum occurs pi over 4 units to the right, and then it hits a maximum and starts decreasing. So if we were using a cosine function, there would have to be a phase shift of pi over 4 units to the right. And so that would allow us to write another function, y equals 2 cosine of 2, and then parentheses x minus pi over 4 minus 1. That is one way to do it. But a trickier, but also much more efficient way is to remember that sine of x, a sine function, is the same or is equal to a cosine of the same x value minus pi over 2. And we did that by looking at the parent functions and thinking about phase shifting cosine pi over 2 units to the right. And so if we have a sine function with some argument, and that's what we have, a sine function, and our argument is 2x, we simply needed to write it as a cosine function, keep the same argument, and subtract pi over 2. So what we would do, and I will write this over here, is we would write this as y equals 2 cosine. I keep the argument the same. That argument, 2x, has the same place as this argument x in our equation, right? We keep the argument the same, just subtract 2x. So it will be cosine of 2x minus pi over 2, notice the lack of parentheses, minus 1. And you might say to yourself, well, isn't this different than the cosine function we found here? But in fact, it's not. Notice that here we could distribute the 2 in, and we get 2x, and then 2 times pi over 4 would be pi over 2. So we get exactly the same thing. And similarly here, if I wanted to factor out a 2 so that I had x minus h, what I would end up with is 2, and then that 2 is factored out, so then it's x minus pi over 4 minus 1. So I've decided to design my own Ferris wheel, and I encourage you to play around with it and try some different ones and maybe get creative. Tamir made his go underground, which is pretty cool. But basically, my initial position is 5 feet above the ground. It's going to go all the way up to 65 feet above the ground. And I want to make one full rotation every 3 minutes. And so I can create a function that will do this. I want my midline, right, to be in between 5 and 65. I want my period to be 3 minutes. And I want an initial position, a y-intercept, at the minimum. So with that in mind, I can create a function. All right, so let's go ahead and start putting our function together. Noticing that the maximum value up here is going to be 65, and the minimum value is going to be 5. Halfway in between that is going to be at 35. So my k value is going to be 35. I also know that the amplitude is the distance from the midline to my maximum, which is going to be 30. I know that the b value, the b parameter, is going to be related to the period, and so my period is 3 minutes, and so 3 is going to be equal to 2 pi over b. And if I solve that, I get that b is equal to 2 pi over 3. So now I can go ahead and start thinking about whether I want to use a sine or a cosine function, and notice that I want to start my cart at the bottom, at the minimum value. Well, a cosine function with no phase shift would have a y-intercept, or an initial value, at its maximum. So if I want to change a maximum to a minimum, I simply need to reflect over the midline or make my a value negative. So now I can put together my function that the height, which depends on the time, is going to be negative 30 cosine. B value is 2 pi over 3 times t, not x, times t, plus 35. And then you can think about how you might change that into a sine function if you wanted to, using the fact that, that we know where if we have a cosine function, cosine of x, that's the same as taking a sine function and phase shifting it to the left pi over 2 units. So the thing that you just have to remember here is that your argument of your cosine function is this whole piece here. Right? So I encourage you to play around with this and think about some other situations where you could use a sinusoidal function as a model. Notice why a Ferris wheel works so well, and think about some other things that have that same characteristic. Last but not least, we could graph this function. Right, we're starting at a minimum. We'll have another minimum 3 minutes later. In between that, it will hit the maximum, so on and so forth. All right, so you can go ahead and finish out your graph, and good luck studying.